Established in 1916, the ICAR, Central Plantation Crops Research Institute, is pioneer in developing coconut production, protection, and processing technologies. Research accomplishments from this institute include world's first hybrid in tree crops, light interception and root spread studies, evolving cropping system models and integrated mixed farming systems, and management practices for pests and diseases of coconut. The institute has conducted classical studies on nutrient and water requirement of coconut. CPCRI is first to use biocontrol agents for control of pests and diseases and carries rich expertise in maintaining the nucleus cultures. These efforts also paved way for evolving organic farming practices for coconut. The vegetative growth and reproductive phase in coconut takes place simultaneously. The palm produces an inflorescence at every leaf exile. Continuous supply of nutrients is thus required for coconut to realize its potential yield. Organic manuring ensures slow but continuous supply of major and micronutrients to the palm. Recycling of available waste from coconut garden is an important component of nutrient management under organic farming. A coconut garden of 1 hectare will produce 16 to 20 tons organic waste a year. Recycling of this biomass can meet the requirement in substantial proportion of nitrogen, phosphorus, and micronutrients. A part of the organic waste from the coconut garden is used for mulching. The remaining can be converted to vermicompost using a native species of earthworm called Eudrilus. This earthworm can easily digest the lignin-rich coconut leaves. Vermicompost can be prepared using a cement tank or trenches or the coconut basin itself. Vermicomposting in cement tank ensures better management and speedy composting. The first step is to collect dried coconut leaves and arrange in layers in the tank. For every 100 kg coconut leaves, add 10 kg cow dung. Maintain optimum moisture by sprinkling water. After 3 weeks, introduce 1000 earthworms for 1 ton of coconut leaves. After releasing worms, mulch with locally available organic waste. Maintain adequate moisture at 40 to 50% by sprinkling water whenever necessary. Protect worms from predator birds, rats, and ants by suitable methods like wire mesh, water channels, etc. After 60 to 75 days, 70% of the material will be decomposed, and at that time, watering can be stopped. After 90 days, the compost can be collected and stored under shade. worms are collected for further use. The average nutrient composition of the vermicompost is around 1.2 to 1.8% nitrogen, 0.1 to 0.2% phosphorus, and 0.2 to 0.4% potassium. Organic carbon 17.84%. In a year, apply 30 kg vermicompost in the coconut basin and rake it. When vermicomposting is done at coconut basin, first make a 2-meter radius shallow basin. Then spread 5 to 6 coconut leaves in the basin. And after 3 weeks, add 3 kg cow dung. Add 50 Eudrillus species earthworm in the basin. The basin should be covered with suitable mulch material. Adequate care should be taken for the protection of the earthworms in the coconut basin. In case of continuous rainfall, care should be taken to drain excess water. In the absence of rain, make sure that optimum moisture by providing irrigation. Adequate biomass materials are to be provided as the decomposition progresses. In the event of loss of earthworms, the same has to be added afresh. In a year, 30 kg vermicompost can be Instead of coconut basin, trenches made in the garden can also be used for production of vermicompost. Trenches of size 1.5 meter width and 1 meter depth is used for this purpose. Coir pitch, a byproduct of coir industry, is in good demand for composting. For speedy composting, it is recommended to add 10 kg poultry manure, half kg each lime and rock phosphate to 90 kg of coir pitch. These amendments are applied in layers. Moisture has to be maintained at 50%. planting will be completed by 45 days. CPCRI has brought out biofertilizer formulation Kera ProBio for coconut cultivation to increase availability of phosphorus in the soil. Nitrogen fixing azospirillum species can also be used. Apply twice a year 100 gram of carrier-based inoculants of these biofertilizers in the coconut basin. Growing of nitrogen-fixing leguminous crops in the coconut basin can provide 150 to 200 grams nitrogen. Recommended leguminous crops are cowpea, Furacea, Calapgonium, Sunham and Dencha. Sow 100 gram seeds of leguminous crops in coconut basin with the onset of the monsoon and incorporate the biomass to the basin when 50% of plants start flowering. Green manures leguminous crops can also be grown in the interspaces of coconut. Glaricedia is a perennial source of green manure. Under monocropping system, Glaricedia can be grown as an alley crop. Stem cutting of 1 meter length or seedings can be used for planting Glaricedia. Pruning can be started 1 year after planting and should be done at least thrice a year. Height of the plant should always be maintained at 1 meter by pruning. Glaricedia cutting can also be planted in the border of the coconut gardens. Success of organic farming lies with selection of compatible crops and integration of livestock. Cropping system will provide large quantities of organic matter for recycling and thus will reduce the requirement of external inputs. The canopy structure and rooting pattern of coconut make it possible to grow an array of annual, biennial and perennial intercrops. Pepper, cocoa, nutmeg, clove, cinnamon, banana, pineapple, ginger, turmeric, elephant foot yam, tapioca, etc. are the most commonly cultivated crops in coconut garden. Other compatible crops include groundnut, cowpea, sapota, papaya and a number of medicinal plants. The high-density multi-species cropping system model developed at CPCRI utilized the vertical and horizontal space in the coconut garden effectively and increased the per-unit productivity. This model has been adopted in different coconut growing regions of India. CPCRI is pioneer in integrating dairy and other allied enterprises with coconut farming. The dairy unit is pivotal to organic farming. The cow dung and urine goes as fertilizer for fodder grass and coconut and fodder as a feed to the milch animals. Fodder grasses such as hybrid Napier grass can yield about 120 tons of fodder per hectare in a year under coconut shade. This will be sufficient to maintain 12 crossbred cows. Rearing of goats, poultry and fish farming can also be integrated with coconut farming. The yield of coconut in the organic farming experiment conducted over a decade at CPCRI is more than 100 nuts per palm per year. These models maintained at CPCRI clearly demonstrated the sustainability of organic farming.
Technologies to produce the coconut in a sustainable way through organic farming. Organic farming reduces the input cost and enhances the profitability. Besides profits, organic farming also reduces the pollution, increases the soil health and produces the residue-free product.